welcome to class. In this video we'll be looking at the concept of bearing. Now bearing is one of the applications of geometry to solving problems that deal with directions and distances. So you have in the ancient world, when navigation through seas and oceans were the prevailing means of transport as at then, talk about warfare and trade and commerce, they were all heavily carried out on the sea and oceans using ships. So the concept of bearing was very much prevalent in those days, whereby you need to know the direction at which you are to sail. When you set sail, in what direction, they describe directions, they describe the locations using those directions. So you begin to talk about what was referred to as or what we know as compass. Now, they were very much in use in those days, but as the speed of transportation increased and the means of transportation, the modes also evolved, there were needs to further I'll call it invent new methods of relating distances and directions and all that. But we still want to look at bearing. So the concept of bearing, all right, so you have like an example is, maybe let's say that this is a reference point and someone set out from here. Okay, having it in mind that you have what is called the cardinal points. The major ones are the 4 cardinal points, but we don't only have 4. In the ancient world, they were subdivided into 32 thereabouts. So you have the main one: north, south, east, and west. So you have this reference, this starting point, and someone set out in this direction. Alright, someone set out in this direction and then moved up to this point. Let's also label that place north, west, east, and south. And from there, okay, so the person is going to, let's say the person in question is going to this point. All right, okay, but due to the road construction and everything, there is no straight route for him to move from here straight down there. Okay, it's only when you are using an airplane, so you're using a flight, that you can have a direct route. Otherwise, there is always a branch out. You go there, climb the bridge, you come down, you swim and all that. So this person moved from this point A to point B. Okay, it's at point B. Then from point B, it moved down to this point. Let's call here point C. And from here, that point C, at every point you always have the 4 cardinal points. And then at point C, person moved like this, came to this point, also having north, east, west, and south. And then finally from here, the person moved up and then arrived. Okay, so we have a series of movements. Now when you want to describe this, usually they used bearing to describe motions like this, and that is the purpose of our study. I want to look at the concept of bearing. Now there are basically 2 ways of describing, 3 2. We're looking at the 2 main ways of types of bearing, 2 types of bearing. I want to look at them, the 2 types of bearing. So, but still considering the diagram that we have here, still considering this. Now this person started out from the point A, moved a certain left at point A at a certain degree. So the person moved, and getting to this point, made a turn, certain degrees turn, moved down here. At this point, made also a turn, moved to this point, and then made another turn, and then moved up. So this is a classical case of the bearing. So I want to look at how do we describe these rotations, how do we describe those turns. I want to look at how we describe them. The first one I want to look at is the first type of bearing I want to look at is through bearing. Alright, through bearing. Now through bearing makes reference only to the knots. In your cardinal points, you have the 4 cardinal points. Now you have the 4 cardinal points: the north, the east, the south, and the west. And the two bearings makes its reference point from the north, so you always make a reference point from the north. What that means, and the true bearing also always has 3 digits. All right, so at the point, let me shift this, let me redraw this. Okay, so we have this north, that's not there. We have east here, south, and the west. Now remember I said the true bearing always has 3 digits. Okay, so at the point at the north, what you have there is 0, 0, 0 degrees. Okay, at east, when you are due east, what you have there is 90 degrees. Due south, what you have there is 180 degrees, and somewhere due west, somewhere here, that is, you have 270. All these they're taking a reference from a certain point from the north. So in other words, when you move from the north down to this point, you have moved 90 degrees, but you have moved the 90 degrees. When you move from the north all the way down to this point, that is a 180 degrees. From the north all the way down to this point, that is a 270 degrees. And then when you move from the north back here, you have moved a 360 degrees, and also you are back to 0. You're back to 0 degrees. All right, but then there are in between you can have angles in between. You can have angles in between. So for the true bearing, we always use a 2 digit to note that. Okay, so assuming that someone set out from this point, that should be close to maybe say 70 degrees. Now I want to write that using our true bearing. This is how we know that the person started out at 070 degrees. 070 degrees. You don't say 70. We don't recall them like number. We call them the digits. 070 degrees. So this person set out at a bearing of 070 degrees. That is 70 degrees, but you don't really call it 70. You pronounce it digit by digit. 070. All right. So we can also have maybe a case. We can also have, let's say we have okay, or we can have another case here. You still have your north, your east, your south, and your west, and someone set out from this point. All right, so that could be somewhere around that could be about, let's say, 220 degrees. We'll call that 220 degrees. That's 220. So the person set out at 220 at 220 degrees. That's the bearing at which the person left the point. So this person left this particular point at a bearing of 220 degrees away from the north. All right, so it is not just one direction. Now you can leave from one place to another. So let's look at how that works. let's say someone set out from here. This is point point A, having all the okay, let me make that a bit big. So you have point A here, having the north, east, west and south. So someone set out from point A at this bearing. Okay, so someone set out from point A at this bearing and then got to point B. This is point B, having also the north, the east, the west and the south. So in this case, this person left point A at a bearing of, let's say 155 degrees. That's 155 degrees. So this person left the point A at 155 degrees. So when you want to talk about the bearing of point B from A, so the bearing of B from A is 155 degrees. So the bearing of B, the point B here, from A, in other words, when you get to point A facing north, you will turn, make a 155 or 155 degree turn from the north, and then you move down straight. A distance this here could have this could be x kilometers, it could be any distance. So when you want to describe to someone, you could say that when you get to a certain town A, make a 155 degree turn and then move down x kilometers, could be 10 kilometers, then you get to the base, and so many other ways you could describe that. So in order, the bottom line is that using a true bearing, we use a three digits to describe true bearing. Alright, so when we don't say 60 degrees, 060 degrees and all that. Alright, the next type of bearing is what is known as a compass bearing. The compass bearing, that is, we use the cardinal points to note the directions. Majorly we use the north, the four cardinal points as the north, east, west and south. Now compass bearing, this type of bearing is always an acute angle. An acute angle is an angle that's less than 90 degrees. So the compass bearing is always an acute angle, and it has three components. Which we are going to look at now. For compass bearings, these reference points are always either the north or the south. The reference point, you can start from the north to make your reference, or you can start from the south, unlike the true bearing whereby every reference is made from the north. The starting point is always from the north, you move away from the north. But for compass bearings, you can reference the north or the south. So like I already noted, it's made up of three components. The first one is either the north or the south. Okay, then the second thing is how many degrees away from the north or the south. And the third component is towards direction. Is it towards the east or towards the west? So those are the three components of your compass bearing. It will always have the reference either north or south. Then the next is how many degrees away from the north or the south, and the third one is towards which direction. Is it towards the west or towards the east? Is it towards the west or towards the east? So those are So either you start from north or from south. The next thing is how many degrees away from the north and the south, then towards what is it towards the east or towards the west. So and it is always an acute angle. It must always be less than 90 degrees. Let's look at examples. So let's say we have this here, and we want to describe this bearing here. Now note that this is still northeast, west, and south. So we want to describe this. Let's say that this is here. Let's say that this is 70 degrees. So when we want to describe this bearing, we will say that this is, remember the first thing, the bearing is moving away from the north, so that is north. Then how many degrees away from the north? That is 70 degrees. Towards where? Towards east. So this is north, 70 degrees east. That's how we would call this bearing, that this is in a bearing of north 70 degree east. So this is a north 70 degrees east bearing. All right, look at this one here. Let's say we have this one. Let me make that here. So we have this, and we're having a bearing that moved like this. Remember, this is the points, and let's say that this is maybe 69. All right, so when we want to describe this bearing, now this bearing here is closer to the south than the north, so you don't go all the way up to the north. No, it is closer to the south. So this bearing would be south, that is moving away from the south 69 degrees towards the west. So this is south. Right, that is always in capital letter. So you have south 69 degrees west. That's how you would describe this bearing. That is a bearing of south 69 degree west. So south 69 degrees west. So these are how you name the compass bearing. It will always start either from the north or from the south, followed by the value of the bearing, the angle in degrees, then followed by the direction at which you are set out. All right. Now sometimes you could have a perfect alignment in between the north or the south. You could have a perfect alignment in between, that is going halfway between the north and the east, or north and west, or south and east, or south and west. In other words, when there is a movement, a bearing that cuts just in half of, okay, so let's say we have this kind of bearing here. Let's say we have this, okay, not perfect. Okay, this is better. So looking at this point, you're looking at this line here, this one here, that is halfway between the north and south, and this is what we call a northeast direction. This is a northeast direction. Here becomes southeast direction, here becomes southwest direction, and here becomes northwest direction. And each of them is always 45 degrees. So you have 45 degrees, 45 degrees, 45 degrees, 45, 45, 45, 45, 45 degrees. So north is in a northeast direction is 45 degrees away from the north. In a southeast direction is 45 degrees away from the south. Southwest direction is 45 degrees away from the south. And also northwest direction, in a northwestern, that is 45 degrees away from the north. Now when we say due east, there's another one that we need to also look at. When we say due east, due west, due south, due north. So when there is such statements in a bearing problem that says due east, Okay, so when a bearing problem makes mention of words like due east, as that someone traveled due east. So maybe someone started from here, due east, that is a straight line without branching out. That's on that east direction. The person made a straight movement to another point. Now this due east in this case becomes 90 degrees because in between the north and the east is a 90 degree. Also due east, that is 90 degrees. Due west likewise is also another 90 degrees. All right, so those are some keywords to watch out from. Then the other one is the word. The other keywords that we need to watch out for in our bearing problems is the other ones. Let's look at the words from and to. So these two words, from and to, you need to be careful of how they are used. From, for example, let's make a drawing to illustrate that. So we're having, let's say that we have a movement. Okay, let's make it bigger. So let's say we have a movement. Okay, so we have this. Okay, so we have 2 points here, labeled point A and point B. All right, so when we look at this, the one here, so bearing of point A, bearing of point B from A, the bearing of point B from A is the value of the angle that we have here. That is the bearing of point B from A. It depends on which type of bearing you want to use. If you want to use the true bearing, that would be the value of the angle here. All right, so when you want to use the true bearing, that means that the bearing of point B from A would be the value of the angle here, and that could be let's say somewhere around maybe 140. That could be 140. So when you want to describe the bearing of B from A using the true bearing, you could say that the bearing of B from A is 140 degrees. However, when you want to describe the bearing of B from A, you're making your reference, you're starting out, you're going away from A down to B. So the bearing of B from A will be the smaller angle here. Remember that you always measure the side where you have the angle closer to either the north or the south. Now the angle is closer to the south than the north, so for a compass bearing you would make use of the south. So this angle here could be 40 degrees, and when you want to describe this, but you would say that the bearing of B from A is south 40 degrees east, because you are start moving away from the south 40 degrees towards the east direction. So you see that these two bearing, they equate to each other. So in a true bearing of 140 degrees, is equivalent to south 40 degrees east for a compass bearing. So you see there's a conversion here that we can easily pick out. We can easily take it out, the conversion between true bearings and the compass bearing. That will lead us to the next thing that we want to look at. That's the relationship between the true bearing and the compass bearing. So once you look at that relationship, how we can easily switch those bearing. For example, problems could come asking you to state the equivalence of a given bearing. Maybe it could be a true bearing. You're asked to state its equivalence in true bearing, or it could be a true bearing. You'll be asked to state the compass bearing equivalence of that. So either way, you need to know how that works. So let's look at an example. We have, let's say that we have something like this. We have this, and this is a true bearing of 160 degrees. So this is a true bearing of 160 degrees. Now if we want to convert this to a compass bearing, if you want to convert that to a compass bearing, assuming that is the same thing. Now what we want to look at, the point, this point is closer to the south, so we're looking for the value of the angle between the south and that point. And of course, you know that moving from the north all the way down to the south is always 180 degrees angle on a straight line. So for us to get what is here, so for us to get the angle that is here, we know that here already is 160. So 180, we would say 180 minus 160, that will give us 20 degrees. So that means that the angle that we have here is 20 degrees. And to describe this using a compass bearing, that would mean, so for us to describe here using a compass bearing, that would be south, that's the reference point, we're starting from the south, moving 20 degrees towards the east. So we have that south 20 degrees is equal to 160 on it for a true bearing. So south 20 degrees is equivalent to the 160 for a true bearing. And that you could also try to convert from compass bearing to true bearing. Say we have a bearing like this, maybe we have this bearing here. Okay, now let me get a bit. Let's say we have this bearing here, a compass bearing that is labeled so this bearing here could be south 60 degrees west. Now if we want to convert this south to 60 degrees west to a true bearing, what would that be? Remember that the true bearing will always make a reference, start a reference from the north, and you always move in a clockwise direction. So you don't go like this, you always move in a clockwise direction. That's how you move for a true bearing. So in other words, what we are looking for is the value from here. So we're looking for the value from here all the way to here. Alright, but we already have the value of some of the parts. So from here to here, we already know the value at 60 degrees. What we are looking for is the value of here to here. And just looking at it, you see that is an angle on a straight line. That is, so the value from here to here is 180 degrees. Therefore, totaling them, that is from here all the way down here, will be 180 degrees plus 60 degrees, and that will give you 240 degrees. And so it means that south 60 degrees west for a compass bearing is equal to 240 on a true bearing that always references only the North Pole. So this is a case of the bearing. We're still going to look at how we can apply this bearing to solve problems that dealing with distances. Okay, we'll still look at that, but for now we're just looking at the basic concept that we need to master: the concept of compass bearing, the true bearing, which is always a 3-digit number, Then the compass bearing always having three components, either the north or the south, then the degree value, and then what direction. Not forgetting that when you have a northeast direction, that would be 45 degrees, northwest, southeast, southwest, those are halfways in between the east and the west, east and the north and the east, north and west, south and east, south and west. That's where you have all those, and they are all 45 degrees. And when you travel due east, due west, due north, due south, depending on the given diagram, you're likely to always have 90 degrees. Always to have a 90 degrees. All right, so that's that for this video. In the next video, we'll be looking at application of bearing. We'll be looking at application of bearing as well as the concept of reversed bearing. So we'll be looking at that. So I'll be seeing you in the next video. Bye.